This is video number 6 for integrated 2, focusing on polygons. A major focus on this one, though, was talking about ratios of similarity. The 3 ratios that we focus on are side length ratios, which are also called a zoom factor or a scale factor, a linear factor, the ratio of similarity itself. So we do side lengths, perimeters, both of which are the same, and then we focus on areas as well. In future math classes, you'll talk about volume. Okay, so what we want to do, again, I'm following the directions off to the side. We want to state the perimeter and area ratios given the ratio of similarity. Okay, if we were told this is the ratio of similarity, the understanding is that this is going to be the side length ratio. So I would say that the side ratio, which we also call R, is going to be 7 compared to 4. Now, this can also be written as a fraction if you choose to. It's not necessary, though. Now, the perimeter ratio is the same as the side ratio. So this is also R, which means this is also 7 to 4, which can be written as a fraction. Now, the area ratio is where things get a little bit different. The area ratio is actually R squared. So we're going to take, and I'm going to use the fraction part of this, the R from the other two, and you're actually going to square them. Remember, to square a fraction, you can square the top and the bottom independent of each other, so you can actually rewrite it as 49 over 16 or 49:16. Okay, I want to state the perimeter and the side ratios given the area ratio, right? So this time we're given R squared. So the area ratio, R squared, is going to be equal to 1 to 36, which we know we can write as a fraction, 1 over 36. Now, if we want to find the side ratio is actually R. So what we're going to do is we're going to take the R squared and we're going to square root it. When we do that, we get 1 over 6, which we know we can write as 1 to 6. Once we know the side ratio, we can identify the perimeter ratio, which is also R, so 1 over 6 or 1:6. Okay, some examples here, or an example here. 2 polygons are similar. Okay, good. The smaller polygon has a perimeter, okay, so perimeter of the smaller one is going to be 20, and an area, okay, so the area of the smaller one is 70. So we've got the area of the smallest going to be 70 square centimeters. Okay, if the perimeter of the larger polygon, okay, so perimeter of larger, try to keep these organized next to each other. So perimeter of larger is going to be equal to 55. We want to be able to find the area of the larger one. All right, well, you know, make sure that we don't mix up the perimeters and the areas together. I want to do perimeter with perimeter, area with area. So now I'm going to focus on the perimeter with the small and with the large. I'm going to go ahead and rewrite these guys as a fraction. It doesn't matter which one you do. You could do small over large or large over small. It's ultimately up to you. I'm going to go small over large. So for my perimeter ratio is going to be 20 over 55, which I could simplify, might make it a little bit easier, but I don't have to if I don't want to. Now, knowing that the perimeter ratio is also identified as R, like we did previously, in order to find the area comparison, remember that the area one is going to be R squared. So I'm just trying to organize my stuff here. So for my perimeter, this is going to be R, and then for my area, this is going to be R squared. So taking a look, this is my perimeter ratio. This is R. I need R squared. Well, in order to find R squared, I am going to take the 20 over 55 and I am going to square it. So now remember that we can square the top and the bottom independent of each other. So we know that 20 squared is going to give us 400 and 55 squared is going to give us 3025. This is still the small on top and the large on the bottom. I can tell just by looking at the numbers themselves. So now let's go back here. So the ratio for the areas is going to be 400 over 3025. Well, we know the area of the smaller one is 70. That was given to us. We're trying to find the area of the larger one. So let's call this x. So now I'm going to cross multiply. So that's going to give me 400x is equal to, and then we're going to take that 3025 and we're going to multiply it by 70. That's going to give me 211,750. Go ahead and divide by the 400. Those are going to simplify, and this is going to give us x is equal to, it's not even approximation, it's kind of nice, 529.375 units squared. So that means that the area of the larger polygon is going to be 529.375 units squared.